This video covers section 6.3, factoring trinomials of the form ax squared plus bx plus c, where a is not equal to 1. Objective 1, factor ax squared plus bx plus c, where a is not equal to 1, using grouping. In this section, we will look at how to factor when the leading coefficient is not 1. This is harder than section 6.2, where the leading coefficient was 1, because it adds more possibilities. With these types of problems, we will introduce you to grouping. Grouping is a factoring technique we used to factor four-termed polynomials. We will figure a way to make our trinomial have the four terms and then factor it by grouping. Example 1, factor the trinomial completely by grouping. The method that we use is called the AC method. In section 6.2, when we factored trinomials whose leading coefficient was 1, we only looked at the C value. And in those problems, the A was always equal to 1. So if we took A times C, it would have just been -8. But in these problems, it's all about the product of two numbers that is A times C. A times C is 3 times -8, which is -24. The product of two numbers that's -24 and whose sum is equal to B. So we first find the value of A times C. 3 times -8 is -24. Then we find our pair of integers, m and n, whose product is AC and sum is B. So we're looking for two numbers that multiply to get -24 that adds to -2. We have 1 and 24. We have 2 and 12. We also have 3 and 8. And the last pair is 4 and 6. But one of them needs to be negative to get -24. But thereafter, it has to add to -2. So we will place the negative on the larger number and see which of these adds to -2. The first one's -23. The second one is -10. The third one's -5. And the fourth one's -2. Our pair of numbers are 4 and -6. Then we have step 3. Write our trinomial using the m and the n in the middle. So we chose 4 and -6 because they have a sum that's -2. And that means we can replace -2x in our trinomial with 4x minus 6x. Then we get 3x squared plus 4x minus 6x minus 8. Now we have a four-termed polynomial where we can factor by grouping. The first pair, when we factor by grouping, we look for the GCF, and their GCF is an x. When we factor out an x from those two terms, we divide them by x, and we're left with 3x plus 4. From my second pair, when I look at -6x minus 8, I see a GCF of -2. When the third term is a negative, factor out a negative. Dividing both these by -2, -6 over -2 is 3, and -8 over -2 is 4. Now we have a common binomial. We factor that off to the right-hand side, And we're left with 3x plus 4, and the remaining pieces are x minus 2. Giving us x minus 2 times 3x plus 4. As always, you should check this. X times 3x is 3x squared. X times 4 is 4x. Negative 2 times 3x is negative 6x. And negative 2 times 4 is negative 8. 4x minus 6x is negative 2x minus 8. So this factors as x minus 2 or times 3x plus 4. Example 2. Factor the trinomial completely by grouping 10z squared plus 21z plus 9. Our a is equal to 10. Our c is equal to 9. The first step in this process is to find the product of a and c. So we want two numbers whose product is 90. That adds to b, which is 21. Two numbers whose product is 90 that adds to 21. 1 and 90 is way too big. 2 and 45, still too large. 3 and 30 is 33, but we see we're getting closer to 21 now. 4 doesn't go into 90, but 5 does. 18. Now we're down to 23. And 6 goes into 90. 15 times, and there's the 21 that we're after. Now we have to replace the 21z with the sum 6z plus 15z. We get 10z squared plus 6z plus 15z plus 9. And now we factor by grouping. Our first pair of terms, 10z squared plus 6z, has a GCF of 2z. Figuring out what's left over, we divide both terms by 2z, giving us 5z plus 3. My second pair, 15z plus 9, has a GCF of 3, so we factor out a plus 3. Dividing both by 3, 15z divided by 3 is 5z, 9 divided by 3 is 3. We have produced a common binomial. We factor it off to the right-hand side. 1 factor of 5z plus 3, and the remaining pieces are 2z plus 3. 2z plus 3 times 5z plus 3. This leads me to your practice problem. I encourage you to press pause on your video, and when you're ready, press play and come back and see the solution worked out. Now that you've had a chance to work this out, I'll work this out for you. In this problem, a is equal to 3 and c is equal to 10. The first step is to find the product of a and c. And so we want two numbers whose product is 30 and whose sum is equal to b. which is negative 17. So we search for these numbers. We can use 1 and 30. But since we wanted to add up to a negative number, the positive product means we need two negatives. And those add to negative 31. Negative 2 and negative 15 is negative 30, and they add up to negative 17. We've found our pair of numbers. Once we find our pair of numbers, we replace the negative 17x with negative 2x minus 15x. We have 3x squared minus 2x minus 15x plus 10. And now we factor by grouping. From the first pair, we factor out an x. Dividing both of these by x leaves me with 3x minus 2. From my second pair, we have a greatest common factor of 5, but when the third term is a negative, we factor out a negative 5. Dividing both terms by negative 5, negative 15 divided by negative 5 is 3, and 10 divided by negative 5 is negative 2. When we produce the common binomial, we factor 1 off, and we're left with 3x minus 2 on the outside, and then on the inside is x minus 5 left over, giving us x minus 5 times 3x minus 2. Example 3. The first thing that comes to mind when I look at that is the negative in front of the 20n squared. I don't like those negatives, so I'm going to factor it out. But then I look further into this and I see that everything here is divisible by 2. So I'm going to first factor out the GCF of negative 2. Dividing everything by negative 2 gives me 10n squared minus 11n minus 6. Now I have the negative 2 out. It's just going to go along throughout the problem, and it's going to be in our end answer. In factoring the trinomial, we need the a, c, product of two numbers, that's a times c, which is 10 times negative 6, or negative 60. That adds up to b, which is negative 11. So we're looking for two numbers whose product is negative 60. 1 times 60. One of them needs to be negative, and the sum needs to be negative, so we place it on the larger one. 2 and negative 30. 3 and negative 20. 4 and negative 15. We've found our pair of numbers. So we replace the negative 11n with (4n minus 15n). We factored by grouping. Our first pair has a 2 in common. Dividing everything by 2 leaves me with 5n plus 2. But I also need to recognize they both have an n, so I'm going to factor out a 2n from those two terms. When I take 10n squared and divide by 2n, I'm left with 5n. 4n divided by 2n is 2. From the negative 15n minus 6, I'm going to factor out a negative 3. Dividing by negative 3, negative 15n divided by negative 3 is 5n, and negative 6 divided by negative 3 is positive 2. When I produce a common binomial of 5n plus 2, I factor it off to the right-hand side, and then what's left over is 2n minus 3. And so remember that 2, or negative 2 that we started with, is still out in front of all of those pieces. So we get negative 2 times 2n minus 3 times 5n plus 2. This leads me to practice 2 for you to try. I encourage you to press pause on your video and come back when you're ready to see the solution worked out. Now that you've had a chance to work this out on your own, I will work this out for you. A is equal to 10, and C is equal to negative 24. So we want two numbers whose product is negative 240 and whose sum is B. Well, B is negative 1 because of the negative xy. So we want a sum that's negative 1. So we ended up with a pretty big product number this time. 1 and 240 is way too far away because we know that since it's a negative 240, one of them has to be negative, and the sum needs to be negative, so we place the negative on the bigger one. 2 and negative 120. 3 and negative 80. We're still pretty far away here. 4 and negative 60. 5 and negative 48. 6 and negative 40. 7 doesn't go in there, but 8 goes in there negative 30 times. 9 doesn't go in there, but 10 does, negative 24. 11 doesn't go in there. 12 goes in there negative 20 times. 13 doesn't go in there, and 14 doesn't go in there either. And 15, let's see, 15 goes into 240. $16 times. There are the pair of numbers that have a product of negative 240 that adds to negative 1. So this time, because of the xy in there, we're going to replace the negative xy with 15xy minus 16xy. And now we factor by grouping. Our first pair, we factor out a 5x. Dividing that by 5x leaves us with 2x, and dividing 15xy by 5x leaves us with 3y. From a negative 16xy and a negative 24y squared, we have a GCF of negative 8y. Dividing that by negative 8y leaves us with 2x. Dividing that by negative 8y leaves us with 3y. We have the same binomial twice, so we factor 1 off to the right-hand side. And what's left over is a 5x minus 8y. Checking this one, first terms gives us 10x squared. Outside terms give us 15xy. Inside terms give us negative 16xy. And last terms give us minus 24y squared. Middle pieces are negative xy. And the last piece is negative 24y squared. So that works. 5x minus 8y times 2x plus 3y. This concludes the video for section 6.3, factoring trinomials of the form ax squared plus bx plus c where a is not equal to 1. Objective 1, factor ax squared plus bx plus c where a is not equal to 1 using grouping.